Hello there guys, and welcome back to another epic Inexorable video. In this video we're taking a look at parallel lines and perpendicular lines, okay? So again, we're just going to read some notes off the board as always. If two lines are parallel, they have the same gradient. That should be like sort of intuitive, if I can speak, should be intuitive because, I mean, think about it. If two lines are parallel, allow me to consult a coordinate axis for you guys. This is the x-axis, and that's the y-axis, as always, and that's 0. I'm not even going to make the joke about how bad my writing is. Okay, so, two lines. Doesn't matter what the lines are. I'm going to draw any line, random straight line. Let's draw a line that goes like that. Why not? You got to pretend that I drew it with a ruler, okay? I know I didn't. Imagine that's a straight line. Okay, think about it. Think about how many parallel lines to this one exist. How many? Give me a number. Well, it's actually an infinite number, isn't it? Think about it. An infinite number of lines are parallel to this one because this line is one of the lines, but also a line that goes like this is parallel to, and this one is parallel, and this one is parallel, and this guy over here is parallel, and so on and so forth forever. But you could draw an infinite number of those lines because you have an infinite amount of space. And the lines are infinitely thin anyway, so you can basically have them touching each other. So these are all parallel to each other. And look at them. They've all got the same steepness, they've all got the same gradient, which means all parallel lines have got the same m in y equals mx plus c. If two lines, let's say like the line, oh no, y equals 2x plus 1 and y equals 2x minus a third, they must be parallel. One of them is going to be sort of like above the other one, but they're both going to be parallel to each other because they have the same gradient. It's that 2x, it's the 2 that gives the steepness of a line, okay? So if you have two lines with the same m value, the same gradient, they are parallel, okay? Likewise, perpendicular. Perpendicular is of course the opposite of parallel. If two lines are perpendicular, then they touch each other at right angles like this, okay? But they could be at any orientation. They could be like this, they could be like this, they could be like this. Doesn't matter what orientation, but they can't, like this, can't do this. 90 degrees, those lines are perpendicular. And it turns out that if you have perpendicular lines, the gradients of both of them will say that the gradient of the first line is m1 and the gradient of the second line is m2. The gradients m1 and m2 have this relationship in which m2 is negative 1 over m1, or the negative reciprocal as I've written. And vice versa, you can rearrange the equation to get m1 equals negative 1 over m2. And you can rearrange the equation again to get m1 times m2 equals negative 1. They all mean the same thing. You don't necessarily need to remember all three of these formulas. I would just remember either if there are two. If you want to find the perpendicular gradient of a line or the gradient of a line that's perpendicular to one that you're looking at, you take that number, you make it negative, or you make it the negative of what you're talking about. So for example, if you have the number 3, make it negative, turn it into a minus 3. Or if you have the number minus 5, make that the negative version of minus 5, which would be positive 5, basically times it by minus 1. And then do the reciprocal of that new number. So if you had the number 3, you'd have negative 3, and then you do the reciprocal of negative 3, which would be 1 over negative 3, or negative a third, and so on. And that would be the gradient of a line that is perpendicular to the one that we're talking about, okay? And don't worry, we'll get into all of that in a second. We'll actually put some numbers on the board in a second. But that's what you need to remember. You can also remember that the gradients of two perpendicular lines multiply together to make negative 1 all the time. If neither are satisfied, m1 does not equal m2, and m1 does not equal negative 1 over m2 or whatever, they're not perpendicular or parallel, and that's totally fine, and that can happen. So we've got 5 questions on the board. The questions, although I haven't actually written it, but the whole idea is, are these lines perpendicular or parallel? That's the question. figure out whether they're perpendicular or parallel. We're going to have a go at that. So let's just go. So I've labelled them L1, L2. Doesn't mean anything. We just want to know is, are these two parallel, perpendicular, or neither? These two, these two, these two, these two. So let's look at question 1, okay? So remember, guys, the only thing that decides whether a line is perpendicular, parallel, or neither is the gradient, which means the constant, the plus c, is not even part of this problem. You don't need to worry about it. It's totally irrelevant. So just look at the gradient. Just look at the m's. The m of this L1 is 4, and this one is -1/4, which means because these two, 4 and -1/4, do indeed multiply together to make -1, they are perpendicular. So I'm going to write here, if I can spell, perpendicular. That's the question 1. Question 2, guys, let's think about this. Y equals 2/3 x minus 1 and y equals 2/3 x minus 11. Parallel, perpendicular, or neither? Well, the gradients are the same. 2/3, 2/3. These guys are parallel. Boom. Okay, question 3. L1 is y equals -3x plus 2. L2, y equals 1/3 x plus 5. Let's look at the gradients, the m's. -3 times 1/3. That's -1, so these guys must be perpendicular. Oh, if I can spell again. Okay, perpendicular. That looks like an or, but it's an A. That's an A right there. Perpendicular. I can spell, I promise. So, question 4. This is where it gets a bit harder because, guys, in this question, look at what we've got. We've got the alternate form of a straight line. Remember from, I think it was the previous video, we were talking about the alternate form of a straight line in the form ax plus by plus c equals 0. Question 4 and 5 are in this form, which is going to be a bit harder because what we need to do is put them back into the form y equals mx plus c, because right now we cannot evaluate these gradients. Okay, so let's actually rearrange both of these. I'm going to have L1 over here. This actually does need some working out. So L1, we're going to keep track of everything. We need to basically make y the subject. I reckon we should add 5y to both sides. We're then going to get 4x plus 1 equals 5y, okay? Because we've added 5y to both sides, I hope you can see that. And then what I think we should do is, well, I'll tell you what, I will rewrite this, I'll write it above. We'll just swap the orders around. 5y equals 4x plus 1. So all I've done is I've just swapped these guys around. Haven't actually done anything mathematically. And then, guys, we don't want 5y, we want y. So for some reason we're going upwards, but we're going to have y equals, we're going to divide everything by 5. So 5y divided by 5 is y, and we're going to divide this and this by 5. So we're going to get 4/5 x plus 1/5. So this is the gradient of L1. Let's find the gradient of L2. L2. Okay, again, let's do the same thing. Let's add 10y to both sides because we've got a minus 10y here. So to add 10y to both sides, we're going to say, I'm going to do it the other way around. So 10y is going to equal 8x minus 2, okay? So basically what I did here, don't be confused, I've added 10y to this side, so we get 8x minus 2 equals 10y, but then I just like up here, I swap them round. So instead of 8x minus 2 equals 10y, we've got 10y equals 8x minus 2. They're the same thing, I just did it to save time, so this is the same thing, okay? Hope that step makes sense. We just added 10y to both sides and then moved the left-hand side and the right-hand side and swap them over to each other. Okay, and guys, again, we don't actually want 10y, do we? We want y, so let's divide by 10. Y is going to be equal to 8 over 10x minus 2 over 10, which implies, we're going to simplify those fractions, 8/10, y is going to be equal to 4/5 x minus 1/5, okay? Because we just simplified the fractions, divided top and bottom by 2 here, and 2 here as well. And so we end up with this guy here, which is 4 over 5x plus 1 over 5, and 4 over 5x minus 1 over 5. Looking at the m's, 4/5, 4/5, they're the same, they must be parallel. So this guy is going to be parallel. Okay, and I'm just going to rub off some of that stuff that we drew so we have space at the bottom. Okay, so don't you guys worry. Okay, question 5 finally. Let's come down here. Okay, again, same procedure, although this might be a bit easier because we've just got a 1y here. So let's add y to both sides. We end up with 5x plus 2 equals y, which means, again, if we just swap the left and the right hand sides, we get y equals 5x plus 2, just like that, and that's actually done. We don't need to divide by anything because it's already on its own. And then for line 2, we're just going to essentially, we've already got a positive y here, so actually instead of taking and adding y's, we're going to take the x's and the constants and bring them to the other side because we've already got a positive y here. So we're going to end up with 10y, and then we're going to take away 2x and add 4. So it's going to be 0 minus 2x plus 4, which is just 10y equals 2x, negative 2x plus 4, just like that, okay? So we did that in one step, but hope that shouldn't be a problem. And again, we're going to come up here. We're going to divide everything by 10. We're going to get y is equal to minus 2 over 10 x plus 4 over 10. And that is going to imply that, again, if we simplify this fraction, we get y equals minus 1 over 5x plus 2 over 5. 4 over 10 is 2 over 5, minus 2 over 10 is minus 1 over 5. So again, these are the things that we're looking at. We're looking at this one, we're looking at this one. So here's our gradient, 5 minus a fifth. What we're looking at, well, 5 minus a fifth, they times together to make negative 1, which means they must be perpendicular. So these guys are going to be perpendicular. Just like that, okay? So perpendicular rather, parallel, perpendicular, parallel, perpendicular. And that is basically how we do it. So if you ever need to figure out whether a line is perpendicular or parallel, you just essentially go through this algorithm, decide whether m1 equals m2 or whether m1 equals negative 1 over m2 or whether m1 times m2 equals negative 1, however you want to do it. Just identify the pattern, spot it, and then you'll know. Again, if neither are satisfied, so let's say you have two lines, again, it could be like a fifth and 5. Well, a fifth is not the negative reciprocal of 5, which means they're not perpendicular. Even though it's the reciprocal, it's not the negative reciprocal. So again, it's not perpendicular. And vice versa. If you have like 3 and 5, they're not parallel or perpendicular. They're just neither. But for us, these have all been parallel or perpendicular, okay? So I'll do a second part of this video where we'll look at like actual problems involving these because they can get a little bit elaborate, I'm not gonna lie, and we'll inspect those in that video. Thank you guys so much for watching, I highly appreciate it, and I will see you in the next one. Cheers.